Hello, everybody. I'm just kind of giving everybody a minute to show in the participant counts, is waiting for it to kind of level out to make sure people are getting in, and we'll get started here in just 1 minute. Cool. Well, hello, everyone, and welcome to today's ACM Tech Talk. This webcast is part of the ACM's commitment to lifelong learning and professional development, serving a global membership of computing professionals. My name is Michael Hilton. I'm an associate teaching professor at Carnegie Mellon University. I'm the director of the software engineering minor. I wear a lot of hats there. My research is mostly focused on flaky tests and continuous integration and the such. I've known Mauricio for quite some time now, and I'm excited about today's talk. I think it's going to be a great one. I'm also a member of the ACM. We can go to the next slide in a minute. Okay. For those of you who may be unfamiliar with the ACM or what it has to offer, here's a little slide with some more information. The ACM offers educational, professional development resources. So you can see all the highlights on the screen. I'm not going to read them all out for you, but I think most of us here are familiar with the ACM. Obviously, things like the digital library, leading publications. There's, the Turing Award, computing prizes, the ACM Code of Ethics, which hopefully we're all familiar with. If not, I would recommend that you go familiarize yourself with these when you get a chance. There's a lot of really great resources there. So yeah, just kind of wanted to kind of set the stage a little bit for this and make people aware of that. Before we get started, we have a few housekeeping things I would like to mention. So there is a Q&A. There's a Q&A widget, which is different than the chat widget. And so we will be asking you to put your questions in the Q&A. While Mauricio is speaking, I will be organizing the questions. We probably won't have time to answer every individual question, but I'll be looking for trends and turning those into meta questions to pose to Mauricio. And so hopefully we'll get to be able to answer as many of those as possible. This session is being recorded and it will be archived. You can get an email notification when it's available. Also, you can check learning.acm.org for when that becomes available, which is relatively soon, but maybe not immediately. After the presentation, there'll be a survey. If you can take time to fill out that survey, that would be super helpful. So I just want to point out there is a question already about will the recording be available, and it actually is. We'll talk. We mentioned that, and then the rest, the technical questions, I'll be collecting them as we go, and we can ask them at the end of the talk. Cool. So today's speaker is Mauricio Aniche, who, and the talk is Effective Developer Testing. Mauricio is an assistant professor of software engineering at Delft University in the Netherlands. He also leads the Tech Academy at Adyen, which is a company that does payments, kind of like a PayPal type of a idea if you're not familiar with it. Mauricio was awarded the Computer Science Teacher of the Year in 2021. And the Delft Education Fellowship. He holds a master's degree and a PhD in computer science from the University of São Paulo, is the author of Effective Software Testing, a Developer's Guide. I know he'll mention that at the end. And he's also a quite passionate Brazilian soccer fan. So, there's that, or football. Sorry, I don't want to offend all of our international guests today. But anyway, I've known Mauricio for a long time. I know this is going to be a fantastic talk. I'm really looking forward to what he has to say. He really is an expert in this area. So I'm going to go ahead and kick it off to you, Mauricio.
Thank you so much, Michael, and thank you so much, ACM, for inviting me. Michael introduced me, so I just want to use this slide to show you a bunch of pictures. So at the top, you can see the beautiful TU Delft campus during the summer. This tall building used to be the one where computer science would stay. On your right part of the image, it's It's our office. I work for Adyen, a payment company, as Michael mentioned. I do lots of different stuff there, from leading the Tech Academy, which is responsible for onboarding and upskilling our engineers, up to different engineering enablement initiatives, testing being one of them, as it is really my passion. At the bottom, you can see the picture of the day I got the printed copy of my book, Effective Software Testing, which is sort of the core of this presentation today. But before we start talking about testing, let me tell you a personal story that will explain to you why I got so motivated to work on testing. So this was back in 2005. I was working for this small consultancy that got a project from a big American company, Verifone, by the way, which is the company that does those POS terminals where you swipe your credit card. And the whole purpose of that project was to automate gas stations. It makes no sense today because all gas stations are automated, but back in 2005, this was not the case. And the idea was, can we build a full application on a terminal? And this application should control the full gas station, right? And then we assembled a small team. I was the one that had some experience already coding for a Verifone's platform, so I was sort of the team lead. And it was the first time I was a team lead. And I thought to myself, this is going to be the best software project ever. We started to develop some stuff. After 6, 7, 8 months, I don't remember anymore, we decided it was time to run a pilot, right? Running a pilot was very hard. This required physical installations in the gas station. And the company decided that the pilot would run in Dominican Republic, right? So for me, it was also my first international trip as a professional, very exciting moment for me, my career. And then we flew to the Dominican Republic. You can see the precise date on this picture, 2006. And there we were. We went to this gas station. We made all the physical installations. We put the software to run. That was maybe 10 a.m. I was there monitoring the software. Everything was fine. I was looking at the logs. Beautiful, no bugs, no exceptions happening. Very proud of what we developed. It was 5 p.m. No bugs. We were in this amazing, beautiful place. We all went to the beach to celebrate what we had just done, right? And I remember being at the beach with the owner of the gas station paying us for the drinks, and the person was saying, this is going to be amazing for us because managing the gas station is a big part of my job, and this is going to simplify stuff. But as you can imagine, life is not that colorful, and there was a bug. And of course, this bug happened during the night when I was sleeping. And the behavior of the software was, there's a bug, I don't know what's going on, so block the pumps. So any person that would try to get the pump and do like this, to get gasoline out, the software would say, no, pump, don't do it. So the gas station stayed quite a few hours without being able to do any deliveries. They woke me up at 5 a.m., 6 a.m. or so. I went there. We turned it off manually, the software system, so that the pumps could go back to manual mode and people could refill their tanks again. I debugged the system. I don't even remember what caused the bug. I patched the application. We deployed again. Everything was fine. But as you can imagine, the owner of the gas station lost his trust on the software system on day one, right? So I spent 1 week there, no other bugs, but the person never trusted us again. And we were doing testing. My team, we were testing the application. A lot of manual testing. We had some Excel spreadsheets that would describe a few corner cases. We even had a pump simulator so that we could really test sort of in an end-to-end scenario what would happen when someone is fueling gas. The pump would send us information through some serial port. We would read the message and etc. So we even invested on this type of things. But most of our tests were manual. And then to me, that was sort of the click, that I had to invest on automated testing. And of course, I knew automated testing already. I studied it at the university. I knew a little bit of JUnit, but I was never really, I wasn't proficient on it. And that was sort of the click to me, like I have to get good at this because that's the only way to build software that works. So many years later, here I am. And the idea of this talk is to discuss a few of the lessons learned over time. And this talk started very small. So I basically wrote the book, and then people started to invite me to talk about the book. And then I made a small presentation, and then people were started to ask me questions, and I started to make this presentation bigger and bigger. I gave it 3 weeks ago, and this presentation took almost 1.5 hours. I'm not going to do that here. So instead of talking about those 12 lessons, I will talk about just a few of them. But later, if you're curious about the full talk, I'll make a video available after this presentation for all of you. So out of the 12 lessons, those are the ones I'll focus today. Trying to be a little bit more systematic. Why code coverage is very important, and we shouldn't really bash it. Unit tests or integration tests, how can we pick these two? Dividing to conquer, the only way to scale tests in complex systems. Testing has to be easy, and test-driven development, yes or no. Yeah. So let's dive into these points. So point number one is about being systematic, right? And the point here is that if you're a little bit more systematic when it comes to create test cases, you're going to just create better test cases. Why do I say this? Let me talk about the research that we conducted a few years ago. Me, my colleague Andy Zeidman, and Christoph Treude from University of Melbourne. And our goal was to try to understand how developers come up with test cases. What did we do? We gave them programs, and we told them, come up with test cases for these programs, and you have to think aloud. So that's what happened, and we recorded all of this, and we analyzed all these videos trying to come up and understand their strategies. And we observed many, many things, out of which I want to mention 2 of them. So the first one is the developers were rarely systematic. You could see them looking at the requirements, because we also gave sort of a small Java documentation of the method that they were supposed to test. So they were not really looking at the documentation and trying to follow the documentation, or looking at the source code and trying to come up with a systematic way to explore it. They were like looking at those things and like, what is the next interesting thing to test? Oh, this test case looks nice, let me try it. They would then automate this test case. They would see it green or red, and then they would say, what is next? And then they would just keep following their hearts, so to say, until at some point they were like, I'm done, I'm satisfied, right? The other interesting thing was, it was very clear to see that some engineers would really focus on the requirements, right? They would look at the requirements, what's the next thing I want to test? And most of the test cases would come up from there. Others would just completely ignore the requirements. They would look at the source code and think, what's the next thing I want to test from it? Very few developers would keep going back and forth, requirements and source code, right? Which is, maybe to my personal opinion here, what makes the most sense. Both give you nice information. So this was sort of the realization to me that developers, they tend not to be super systematic. And in a way, if you look at theoretical books on software testing, my impression there, or my interpretation is that most of the work that we have been trying to do from a research perspective is to sort of come up with a more systematic approach for people to explore software systems and then come up with test cases, right? So think of specification-based techniques, domain testing, boundary testing, all those things you read in books. Behind the scenes, they're just trying to find us a way so that we don't forget about important test cases. And fun enough, this is lesson learned number 1 in this presentation, but definitely the last lesson learned for me in my career. Through my entire career, I would just follow my heart, right? I would just come up with test cases of, when I say my heart, of course, I'm saying, my feeling, my experience as a developer, but I wasn't really following some systematic approach, right? So I was using my experience to come up with test cases. And then at some point I was like, but those techniques are telling me to be a little bit more systematic. Does it make sense? And then I started to try myself to be a little bit more systematic. And I suddenly could see that I then stopped to forget about some corner cases I would normally do. And fun enough, this idea of being more systematic, you see in other fields, right? And in particular, if I come back to software engineering again, I said other fields, I didn't dive so much into it, but you do see this in other engineering fields, medical sciences, etc. But if I bring this to software engineering, you also see this in more recent studies. For example, this one that I'm sharing on my slides. The researchers here, they were trying to understand the differences between experts and novices when doing some software engineering tasks, right? How do these different profiles approach the same task? And what you see on the picture on the left, so this graph on the left is how experts approach. And you see a simpler graph there. So experts sort of know the sequence of steps they need to do to solve the problem. Whereas if you compare to novices, which is the figure on your right, you see that this graph is sort of everywhere, because novices are just, they don't exactly know what the next step should be. So they explore a little bit, they keep coming back and forth until they solve the task. So you sort of see this behavior in experts, right? That they sort of find their own systematic way to solve the problem. So this is sort of my suggestion, number one for you. You're going to come up with test cases. Consider approaches that help you to be more systematic. That will make sure, or at least that will help you not to forget cases that you may otherwise, because your mind is too busy right now with the complexity of the program you're testing. I'm not going to dive so much into this approach, right? But you can read about them. Of course, whenever I talk about this, the big question is, should I then be systematic everywhere? Because, being systematic, being more thorough has a cost. Do I need to pay this cost everywhere? And my experience says, no, of course you don't have to, right? And I think a good argument for that is how complexity works in software systems. So studies show that complexity in software systems are distributed like this. So sort of a power law, where you can see that most of the methods or classes or whatever units of code you have in your system, those are sort of small and not super complex. So for these methods, your experience is probably enough. You look at a 10, 15, 20 lines of code methods, you probably know everything you need to test there. But the tail is very long. And for those very complex methods, maybe your experience isn't enough because there's just too much complexity going on. For these cases, maybe you need some fancier testing technique. And of course, a method doesn't get complex because developers are not paying attention. Methods get complex because those methods are implementing complex business rules, right? So, and maybe those are the ones that you really want to test and make sure it works. And now, personal opinion again, just try it, right? Learn those techniques and try it. You're going to see that it's not really way more expensive. And after you try a little bit, this sort of becomes natural. And I feel like I'm so now used to look of a problem of a program that I want to test, and my mind already starts to do specification-based testing and boundary testing in a more natural way. It's all about practicing as a developer. Then next lesson is about code coverage. And why do I think I need to talk about code coverage that explicit? Because if you talk to developers, it is quite common that you hear developers bashing the idea of using code coverage. And they have lots of reasons for this. They say, for example, I don't want to use code coverage because code coverage is very easily tricked. If I have a test and this test doesn't have an assertion, I'll get to 100% coverage, but my tests are not really catching bugs. Or maybe they say, because if I define a coverage target for my team, say 90%, then the developer will be forced to write useless tests. And I don't want to push for this type of behavior. Another excuse is, I can put a lot of effort in achieving 100% coverage, but that won't mean that my tests are perfect, right? And if this number is not really telling me that my software has no bugs, why should I push so hard to get to this 100% coverage, which we know is sort of hard. And all those points are true. There's a little bit of truth in all of them. You can definitely trick code coverage. If you pick the wrong coverage thresholds, that will force your developers to come up with useless tests, and 100 coverage doesn't really mean your software works, right? But if you use coverage properly, so to say, or if you learn how to use coverage, you can get lots of benefits from it. How should we use coverage? Coverage is not really meant to be a number you just blindly try to achieve. Coverage should be there to help you look for test cases you didn't see before. Let me show you with an illustration. So imagine you just got a feature to implement. You start to implement this feature. Maybe you're doing test-driven development. Maybe you're not doing test-driven development. It doesn't matter. But then, you're writing tests just to help you develop stuff. At some point you're done, and then maybe you then dive into more systematic testing because you want to explore corner cases, you want to explore boundaries, and then you improve your existing test suite. Then the question is, are you done, right? Is this enough? This is where coverage can help you. Coverage will give yet another perspective that you can take into consideration when deciding if your testing is good or not. And then you get coverage, right? You look at the coverage report and then you see, oops, I didn't cover this line of code. Why is that? Why did I forget to cover this line of code? And maybe there's a reason for this. And then you sort of move on. But maybe you forgot about it because you couldn't think of a test case that would exercise that specific path. Then maybe you just go back to your test suite and then you write the test. And you repeat until you're satisfied, right? And see that if you're using code coverage as a way to improve your test suite, there's no number in this game anymore, right? I'm not talking about 90% coverage or 100% coverage. I'm just saying, use this as an extra information to decide if your test suite is good or not. So in a way, the code coverage should help you take the decision, right? It should inform you, give you information, but the code coverage should not be the one taking the decision for you, 90%. Above that, that's amazing. Below that, that's a bad test suite. No, right? You are in control. Now, the $1 million question, right? Is there a correlation between test suites that have higher coverage and test suites that are more strong, test suites that can really review more bugs? Lots of studies around this question, right? As you can imagine, this is a very sexy question for academics to answer. And you see papers ranging from many years ago. For example, 1994, beautiful year. Brazil won the World Cup, as Michael may remember. And I'm not going to talk about soccer anymore because current soccer for Brazilians is not that good. But this paper sort of, the idea behind this paper is if we have different test suites with different coverage levels, 70%, 80%, 90%. And if I start to introduce bugs in the production code that those test suites are testing, which test suite will start to review those bugs, right? Will the 50% test suites find this bug, or is it going to be found only by the 90% coverage test suite, right? And they do, but of course, in a more systematic, scientific way. The results of the paper are, indeed, there's this correlation there. The higher the coverage, the more likely that the test suite is to find bugs. And they show that around 90% is where the sweet spot really is. And those test suites, test suites with 90% or higher, they were really able to find most of the bugs that the researchers were able to introduce in the production code. But they also noticed that 100% code coverage alone isn't a reliable indicator, right? Because you can still achieve 100% coverage, but there may still bugs that slip through the cracks. You see more recent papers, right, from 94 to 2009, and in this gap, we learned a lot about how to do such empirical studies. So what you observe in papers now that try to control for more factors that can influence the experiment in general, that they still show some correlation, although not linear all the times, but you still see some correlation between coverage and test suite efficacy. Something very interesting about this paper is that it argues that if you just want to write the next test, what is the best approach? Random testing, meaning I'm going to just write a test for anything, or writing a test for something that isn't covered yet? The second is more efficient. The second is more likely to reveal a bug sooner than the first, which is, not so different from what we just discussed about how to use code coverage, right? If you use it to look at what you didn't cover so far and then write a test for it, that is a good thing. And you keep going, and you sort of see somewhat similar results in literature. So maybe final thing about code coverage is that high coverage may not mean much, right? So maybe if you're in a software system that has 90%, 99% code coverage for years now, the information is not giving you much. But if you're in a system where code coverage is 10, 15, 20%, that says a lot. That says that your testing is lacking. So use this feedback to improve your testing. And if you're in such a situation, code coverage can be an amazing tool to help you prioritize what to test, right? Because you sort of know the important components of your system. Your developers sort of know, the hot paths of your application. How tested are they? And code coverage can give you this information. Next lesson, unit test or integration test. Which one should we pick? And this used to be a big argument in the community, right? And you have some people that prefer more unit tests. You have some other people that prefer more end-to-end tests. And I think that was a beautiful discussion back in the 2000s, right? But in the 2020s, we learned that the test level doesn't really matter so much, right? What really matters is that we want tests that are very fast and tests that give us good feedback. And you sort of see this idea being spread all over. And if you get the Software Engineering at Google book released in 2018, I guess, there are 3 chapters about testing, by the way. So testing is sort of pervasive there. In one of the chapters, they argue a lot about fast tests versus the slow tests, right? So why do you want tests that are fast? Nowadays, applications are so big, you're going to end up with thousands and thousands of tests. If those tests are not fast enough, you won't be able to run them every second, right? Or at every merge request or pull request, for example, right? Imagine you have, your team of developers, maybe you have 700, 800 developers. Those people are opening up, 300, 400 merge requests a day. If running those tests are expensive, maybe you don't have computational power to do so. What ends up happening in companies, they start to run tests out of the merge request pipeline, right? So think of integration tests that take 1 hour to run. You can't run this at every merge request. So they start to run this every 4 hours, every 5 hours, 6 hours. And that's just, you're delaying feedback to your developers. So tests have to be as fast as possible so that people get feedback as fast as possible. They also have to be easy to be written, right? If writing tests are very hard, people will not do this. And end-to-end tests tend to be harder to be written than unit tests. But if what you want to do is end-to-end tests, then you have to invest in infrastructure for this to happen. And of course, you have tests that will give you the right amount of feedback. If you're testing a component and then you realize that unit testing is not really giving you much information, then maybe unit testing is not the right level, right? Then maybe you should go for integration testing. But maybe you're writing an integration testing, but all you want to do is to exercise 1 unit, then well, go back to unit testing. So I think those are the variables that you should take into consideration nowadays, and stop this discussion that if I'm testing 2 classes together, is this unit testing or integration testing? That doesn't really matter anymore in practice, right? Again, focus on tests that are fast, that are easy to be written, and that give you the right level of feedback. Nice. Next topic, dividing to conquer. And I think this is maybe one of the most important lessons learned for me. And this makes a lot of sense if you're in a very complex environment, where your software system is very complex, maybe composed of multiple parts, because that's the only way to really scale testing. What do I mean by divide by conquer? So imagine you have a very simple system. The system might be distributed maybe over the wire, maybe those are just different libraries that have to communicate with each other. But that's what you have. You have system A, and system A needs to send a message to system B and to system C. System C needs to send a message to system D, and that's how you get the full business rule feature that you're implementing, right? There are many different ways you can approach testing here. One of them is you could just write 1 big test that touches all those modules. So you make a test that triggers some action in system A. System A will really trigger a real action in system B, in system C. System C will trigger something in system D. Your test is waiting for all of this to happen. In the end, your test makes the assertions. That's a beautiful test, right? It really exercises the software system in a way very close to real life, right? That's very close to what's going to happen in production. What are the challenges here? Well, writing this test is very tricky. For this to work, you need to make sure that before you call the action in system A, that system A is ready, that system A has all the data in its database, for example. And the same for system B. You need to make sure that system B is up and running, that all the dependencies of system B, maybe system B depends on a database, maybe system B depends on Kafka, on Hadoop, on whatever other stuff. And all of these things have to be running. Same for C, same for system D. So managing all these dependencies can be really messy. You also need to make sure that all those systems are in the right state for the action to happen. So maybe you need to insert some data in system B before you can start your test, and the same for all the other systems. So very quickly, this becomes very complicated. And I'm not even talking about resources here, right? So if this is going to happen in your CI, now you sort of need 4 Docker images running with those different systems, multiply this by 100 or 200 merge requests a day, this sort of explodes in terms of infrastructure. So, so it is very hard to write this type of test. And funny enough, that's usually what a lot of companies do, right? And that's just a natural approach, because companies start small. Maybe the company at the beginning is just system A, and then suddenly system A gets too big, and then they decide to split A in A and B, right? And suddenly you have 2 systems, and then, well, but I have all these tests already, let me reuse. And the easier way to do this is to just do an integration test. And then this starts to grow, and the integration testing approach starts to scale. But the problem is, at some point, if this really gets bigger and bigger in terms of complexity, this won't scale anymore, also from a people angle, right? In large organizations, maybe you have one team taking care of system A, one team taking care of system B. If your tests, right, you're a developer in system A, if then you start to have to understand so much about system B, then you start to have to make people interact with each other, and that can be a challenge. So in large scale software systems, those things start to be very complicated. So what do I mean by divide to conquer? So what I mean is, you have those 3-4 different systems. The teams that own these different systems, they should be able to test your systems without depending so much on the other systems, right? So your system A, you're going to write lots of tests for system A, and you're going to sort of mock, for example, your interactions with system B. You want to get rid of, in quotes, from system B as much as you can, so that you have all the autonomy and freedom to write the tests. System A depends on a database. Great, maybe you want to write the integration tests that really uses a database in system A, but that's fine because you control system A. System B should be sort of a closed box for you. Of course, this opens up a different can of worms. Now, you have to make sure that contracts, the contract between system A and system B are kept, that the team that maintains system B won't break the contract, so on and so forth. So you sort of have different problems to fix in your organization and in the way you do testing. But this is much easier to scale, because then writing tests for system A only and mocking the interactions with the other systems, this is just much easier, right? It requires way less from you as a developer when it comes to writing tests. It requires way less infrastructure, so on and so forth. So if you're in such a situation, I think the pragmatic choice is you can't test it all. You have to divide to conquer. Of course, you may still want to have a few end-to-end cases that exercise everything together, right? Because we want to see that things wire up all together nicely. And for sure, you can have a bunch of integration tests. But you definitely don't want to exercise, that small if that exists in one code unit of your code base through such an expensive test. You can divide to conquer and get lots of good feedback. That's my current thoughts. Almost there. The other one is testing has to be easy, right? The act of writing tests, it has to be easy. Otherwise, people won't do it. If for you to write a test, you need, to write 50 lines of code, you need to talk to 3 different people, you need to set up 3 databases, 2 web services in a Hadoop cluster. No one is going to do it. It's just too much work. And how do you make testing easy? You have to invest in building infrastructure so that it looks easy, right? So software systems will get more complex. You will need more fancy code to test your application. You have to sort of tackle this complexity and create maybe internal frameworks, whatever you need to make testing to look easy. I'm going to give you a quick practical example. This is a tool we developed at the Delft University of Technology, and this tool grades submissions from our students. So students submit tests, and we want to give a grade to how good those tests are. And this tool behind the scenes, what it does is it gets the code from the student, it compiles, it runs the tests, it calculates code coverage, it calculates mutation coverage, it runs some analysis that was written by the teacher beforehand, it does some static analysis, and then it assembles all these things together, and then it comes up with a grade. When we were building this, we decided that unit tests made not a lot of sense here, because if I, let's say if I mock the compile component, I cannot really run the tests. If I mock the test execution, I can't really calculate code coverage. So for us, it was more natural to put all of this together and start to write integration tests. But that just meant way more work, because we had to really put this entire engine up for every single test. What did we do? We created a small API, let me call it like this, small helper method, utility methods that would simplify the life of the developer. So basically, all you need to do in our integration test is to call this run method, which behind the scenes knows how to put our engine up. As a tester, you just pass the two important input parameters to the engine. The first one is the code that the student is supposed to test, illustrated here by the player points library, the left parameter here, and then an example of a test case that is submitted by the student. So player points, some tests fail. As the name of this file says it all, there are some failing tests there. This run method runs the engine and returns back to us this result data structure, which is a data structure that contains basically everything that has happened in the execution. And that's very nice, because then we can make assertions on it, and very specific ones. For example, the number of tests that succeeded. Is there a failing test called less points? So you see that we turned into something that was sort of complex, meaning running this whole engine, this was complex, and we simplified it so that testers could write simple tests. And this tool was, a lot of it was written by first-year computer science students, right? And as soon as we started to onboard them into this project, it was so easy for them to just look at test examples like these. This is a real one, by the way, and duplicate it, because we sort of removed all the challenges there. And that's what you sort of need to do to make tests easy. You have to look at what makes your life hard when it comes to writing tests. And then you create a library that will simplify this. That's why we build libraries, right? To simplify our lives. Finally, test-driven development or not. Should I do test-driven development or should I not do test-driven development, right? And I was definitely a big fan of test-driven development. And in fact, I even wrote a book about TDD in Brazilian Portuguese back in 2012. And that book sort of explains to people how much I loved test-driven development. But 10 years later, I have a more opinionated, formal opinion about it. And I think TDD wasn't the thing that was making the magic, but it was what TDD made me do, which was working on small sessions with quick feedback, right? How does TDD work? You write a very simple test, right? You capture a very small part of the requirement in the format of a test. You write a little bit of production code, you learn from it, you repeat. And of course, you use this to improve your code as you go, right? To me, the big benefit is that I learned how to work on small bits at a time. Before TDD, what would my coding sessions look like? A mess. I would stay hours in very long coding sessions. In the end of the day, I completely forgot what I had done. I didn't even know where to start coding, and TDD explained to me that I can work on small bits, a little bit of testing, a little bit of production. And today I do TDD way less, right? Most of the times now I really start with the production code, but I definitely learned that I have to work on small bits, and I do a small bits of production code, small bits of test code. So regardless of whether you like to do test-driven development or not, working on small bits and getting feedback from it and improving makes a lot of sense to me. There are lots of papers on test-driven development. You can read them all. I have lots of citations here. What's the gist, right? What do they find? qualitative studies show lots of benefits, right? Developers, they really appreciate doing test-driven development. A lot of them argue that, you know, the design that they produce was better, and etc. But when it comes to more quantitative experiments, you know, really trying to compare the outcomes of people that do TDD and people that don't do TDD, you see small differences overall, right? So you can still do cool stuff, good code, even if you don't do test-driven development. And one of the papers that I like the most, written by Davide Fucci and colleagues, in one of his papers, there's this sentence there that I think it really reasons with me, that the claimed benefits of test-driven development may not be due to its distinctive test-first dynamic, but rather due to the fact that TDD-like processes encourage fine-grained, steady steps that improve focus and flow. And when I read that sentence, I said, oh my God, this is precisely it. That precisely synthesizes what I feel about test-driven development nowadays. Now I understand lots of TDD practitioners, they say TDD helps you to really come up with good design and etc. I have my ways of doing this as well. I think I prefer prototyping a lot nowadays. I'm not going to dive into it so much, but the gist here is, read this last sentence from Davide Fucci and colleagues, and that's what you need to have in your coding process, right? The rest is the rest. This was it. 6 or 7 quick lessons that I learned over time. Most of it is in my book. And the funny thing about writing a book, right? So this book, I think I started to write it 3 or 4 years ago. When Corona started, 2021, that was when I started. And you sort of learn so much about it after you write the book, right? So I think this talk sort of synthesizes most of it. My book is more technical. It dives more into source code and how you can do it with code. But the whole idea is this. Thank you so much for listening to me and Michael. I'm open to questions now.
So thank you, Mauricio, for a great talk. Thank you, everyone. There is a lot of great questions, way more than we're going to have time to get through in the time that we have, unfortunately. But I'm going to summarize kind of some of the big themes that people are asking about, and hopefully we can have a nice question and answer time. So I think there's a lot of great questions, a lot of interesting questions. A couple of these are particularly interesting to me personally, so I guess maybe that's one way we'll do a greedy algorithm here. A couple people ask questions about testing data. A lot of systems are more data-centric than code-centric these days. Do you have any thoughts on that?
Yeah, very cool question. And this question is getting so recurrent in all my talks. So first of all, I've never worked on a very large data project, right? Or machine learning project. So those are basically my feelings. Let me start with traditional enterprise systems, right? Those are also very much database-centric. They use a lot of data. In that type of system, if you're in that type of system, SQL is very important for you. And I feel you have to test your SQL queries very much. I think in the past, we used to say, you know, isolate your code so that then later you can test your repository separately and you can exercise your SQL queries separately. I've never seen anyone writing lots and lots of tests for SQL queries. So my feeling nowadays is, in this type of applications, testing your business logic a little bit together with the SQL makes a lot of sense. Frameworks make it much easier. Spring Boot, for example, if you're in the Java world, it makes so much easier for you to write tests that involve SQL queries. That is sort of what I think right now. In more, you know, machine learning type of systems, I think what makes a lot of sense there is, so first of all, you can write lots of tests for data transformation, right? A big part of those type of systems is about data transformation. You get data, you transform it to something else. For those, you can just write traditional unit tests. I think it makes a lot of sense to write lots of assertions, make sure that your preconditions, postconditions, and invariants are clear. You know, so you just made a transformation and you expect your data frame to have 32 columns, right? So having a clear postcondition that double checks this can help you identify bugs, you know, and maybe it's better to halt the program if one of those postconditions are not met, then keep the execution. So write tests for your data transformation. Unit tests are possible there. Write a lot of assertions, testing from the inside, as I call in my book, right? So you can write lots of assertions to ensure preconditions, postconditions, and these type of things. Now, testing machine learning, right? Is this model really doing what it needs to do? I think that's an open question. that I'm not going to be able to answer, right? And I think this is even an academic interesting question.
Cool, thanks. A couple of people asked, there's several questions about mutation testing. You didn't really bring this up in your lecture, but a couple people have questions about your opinion about that. Can you talk a little about mutation testing?
For sure. So for those that are not familiar with the term, the idea of mutation testing is, if I do a small change in my production code, right? So say I change greater than to greater than and equals to, right? So I introduce a bug. Will my test suite catch this bug? So this is the whole purpose of mutation testing. And the mutation testing tool basically keeps doing these type of changes in your production code, runs your test suite. If the test suite breaks, then you know, hey, good, the test suite is able to catch the mutant. If all the tests are green after the mutant was introduced, then this means your test suite didn't catch that bug. So I love the idea of mutation testing. I think it sort of complements code coverage, right? It gives you more information about how good your tests are. I think the real challenge is how to introduce mutation testing in a scalable way, right? Mutation testing is quite expensive even today. We still are looking for solutions. Google has a beautiful paper called Mutation Testing at Google, published at ICSI Industry Track 2018, 2019, or something like that. And if I remember correctly, the gist was they were sort of trying to even ask help for the developers, right? So the tool would create a mutant. The developers could say, this mutant is useless. Don't use this mutant anymore. So in academia, you see lots of work trying to prioritize mutants, which mutants are important or not. There are even some work now using deep learning to sort of suggest mutants. So I love the idea, but I was never really able to see it running in a large scale software system. But that's just a personal, my personal career, right? But Google, for example, is doing it. If it works in your company, good. I think it just gives you more information.
Cool. So you talked about code coverage in your talk, and I thought that was great. And I actually share your opinion about code coverage. But there was a couple questions kind of reflecting on maybe different types of code coverage, like requirements coverage or risk coverage or criticality of the code coverage. Like people had different opinions about how to kind of augment maybe code coverage with more information. Do you have any opinion on that, or would you like to talk about that for a bit?
Good question. So which code coverage criteria to pick? I think this is really up to the team. There's a paper, it's not on my presentation, there's a paper showing that even line coverage is good enough, right? So if you're in a place where more complex code coverage criteria can't be measured, line coverage is good enough. And I think you really have to understand what type of system you're building. In the US, for example, the FAA, the Federal Aviation requires MCDC coverage, right? Which is a very strict coverage criteria. Maybe, you know, if you're building robots that will operate patients, maybe you want to be more careful. If you're building something simpler than that, maybe a simpler coverage criteria can work. I think this is more of a team discussion, to be honest, rather than one rule, one size fits all type of answer. But definitely discuss this with your team. For me, my traditional rule is branch coverage for most cases, right? So I want to see all my if statements being exercised as true as false. And for very complex algorithms, maybe condition coverage. So maybe your algorithm has very complex ifs with multiple conditions. I think reflecting about the different conditions may make sense in some cases.
Cool, thanks. There's another kind of two sets of questions that are on different topics, but I think they're actually related. And they're talking about both unit testing and mocking. Like when do you stop? Like how low should you go in terms of granularity? There's kind of different opinions about unit testing, how granular they should be, but there's also kind of mocking can get very complex if you take it to maybe a logical conclusion. So do you have any thoughts about that?
For sure, yeah. And this is one of the big fights in the community, right? Because a lot of people say, you should mock basically every component, because what you want to test in is basically the interaction, how objects exchange messages with each other, right? And those are people that really love mocking. And the people that don't love mocking say you should never mock because that will just make things too fake. I think I'm in between both, right? And I usually take the pragmatic approach that is, if I don't mock that class, if I decide not to mock that class, will it be easy to write the test, right? If the answer is yes, it is easy to write the test, then I probably won't mock that class. For example, I just mentioned in one of my first answers that I think you can test your SQL queries together with your components, right? lots of frameworks make it very easy nowadays so that you can, have an in-memory database. And it's very easy to test your SQL queries together with the code, and you don't have to mock your data access objects. So I don't mock them anymore so much, right? I think the decision is, will it really hinder my abilities to write a simple test? So this is sort of rule number 1 to me. Rule number 2 is about focus. What do I want to test? Sometimes all I want to test is that algorithm, right? And I don't care so much about its dependencies, right? That happens a lot, especially when you're implementing a complex algorithm. That is not really about, because a lot of enterprise systems are about get data from the database, massage the data bits, send data back to the database. Those maybe mocks are not useful, but if you're writing a complex algorithm, then all you want to do is exercise that algorithm. So I use mocks to sort of give me focus, right? I can focus on exercising that algorithm. So I think that the point should be, just don't do mocking because of because you either belong to this community or to that community, right? I think you should use mock because you want to be productive when writing tests. I think that's the point, right? Yeah.
Thanks. So, you're the expert. Now it's time for you to make your expert prognostication. It's all the rage right now, but multiple people have asked about, ChatGPT to write our unit tests, AI for writing unit tests. What does the future hold for unit tests? Can you give us your expert prognostication?
I was pretty sure this question would appear because it's been appearing in similar presentations. So I think those tools are great, right? And I feel AI will not really replace humans when it comes to testing, right? I think AI will complement us because as developers, we're very good at writing tests that focus on the business logic. We understand the business, we write tests that make sense to the business. And those tests can't right now be written by AIs, right? But I think AIs are very good to look for corner cases that we traditionally are not very good at, right? So you don't even have to go that deep with ChatGPT, right? But you can think of, a little bit of fuzzing or search-based software testing. Those tools are able to look for cracks that we can see it. So I think as soon as those tools become more common to developers, this is how we're going to use it. We will still be writing business tests, and AI will focus on finding corner cases that we can't. That's how I see it.
Cool. Another thing that I think I can guess the answer to this, but multiple people have said, if you're just starting out, if you're a beginner and you want to get better at testing, what resources would you suggest, or how would you suggest people start moving in the direction of getting better at testing?
To get better at testing, practicing. I think as with most of things in life, you just have to practice, right? And for example, to my first year students at the University of Delft, we give them, 50, 60 different small programs, and we tell them write tests for it. So very focused sort of type of exercises so that they get used to the mechanics of writing a test, so that they get used to the mechanics of specification-based tests and boundary tests. So those very focused practices make a lot of sense to me. If you're just in a big project and you have to write tests, it's so hard. You have so much barriers there. So if your goal is to get better at tests, try to really train, practice like this. And make sure you find time to write tests in your daily job as well, right? It's so easy for us to say, I'm late, let me push without tests. I think this is a culture change that we also need to do.
I'll also vouch for Mauricio's book. It is very approachable to someone who isn't good at testing yet or wants to get better at testing. So I know he mentioned it, but I will also put in a plug for that. We have our students use it, and I think it's great. We have time for just a couple more questions here. So I want to ask just a couple more interesting questions. Someone asked a great question. How much time should you invest in testing after you've deployed your project? Should you stop testing, or do you ever stop testing? What do you think about that?
Yeah, interesting question. So I think testing is just the beginning, right? So you do a lot of testing before, so that you prevent bad stuff from happening in production. But there will still be crashes, right? We develop very complex software systems and we cannot see it all. So I think in practice, you're doing testing to sort of cover 95% of the predictable behavior that you have in your system, and those you make sure it works, right? And you're going to deploy and it works. The other 5%, you just have to have some very nice monitoring in place, so that as soon as the crash happens, you have all the information sent back to developers. They can use it to debug, fix, patch, deploy. And this whole pipeline has to be super straightforward, right? Otherwise, you get a bug report and then you can only push the fix 2 weeks later. That's too late, right? So I think this idea of testing being magic, that was the last point of my presentation, actually, that I didn't cover in this one. Testing isn't magical, right? You will still have bugs. And what do? You monitor.
Cool. Another quick question. Multiple people asked about testing with hardware in the loop. Ultimately, this code has to run somewhere. What do you do when you have like different hardwares, or you maybe don't know your hardware? Do you have any like specific hardware advice for people testing that also need to be conscious about the hardware they're running on?
Very good question. And you know, when I was developing for Verifone, I was an embedded C developer, right? So hardware was an important part of me. I left that world, and then after that, I was just using normal computers, and this sort of became less of a problem. In mobile, what I see people doing a lot is running the same test suite in multiple different cell phones, right? You run it in iPhone, you run it in Android. You see web developers actually doing the same, right? And where you run your tests in the Internet Explorer, Chrome, Safari, etc. So I think if hardware is a big thing for you, you have to find a way to really exercise parts of your hardware, so to say, that are more likely to reveal a bug. What are those parts, right? And how you make it happen is very contextual, but you should put this into consideration as well. Very generic question. I hope that helps. Very generic answer. I mean, I hope that helps.
Cool. Then one last question. Suppose you have you're working on an existing system, and there's a legacy system that doesn't have hardly any tests at all. How do you start with that? Yeah.
First of all, by not setting some coverage thresholds, because that will just demotivate the team, right? I think the second, how to start is prioritizing what needs to be tested. You won't be able to test everything by tomorrow, right? Identify important parts of the system that needs to be tested. Go for the hot paths, right? What are the important paths of this application, and then cover that path. You have a new bug coming up, try to write a test that covers that part. I think indeed you have to tackle testing in a legacy system that has no tests as a project. The second point there is I even recorded a video about this a few weeks ago, by the way. That is, I see lots of people saying, if you're in a legacy system, refactor the system first and then write the tests. That's really too idealistic. That will never happen in real life. It's, maybe refactoring the system is too expensive. No one has time to invest on it. So my suggestion there is accept the legacy that you have today and find ways to make writing tests easier for that legacy. Identify what it makes very hard for it to happen. Create this framework. Let developers write the tests. And meanwhile, maybe one initiative here, one initiative there on refactoring the code. Maybe in the future, the legacy disappears. But I think pragmatically, find ways to test your legacy as it is right now.
Cool. Well, thank you so much, Mauricio. It has been a fantastic talk. Unfortunately, we are running out of time for today. I want to thank you for sharing your insights with us. I think that is really great. I really appreciate this. This talk was recorded. It will be available online within a few days at learning.acm.org. You can also find announcements about other talks and other ACM activities there, or obviously on acm.org. When at the end of this talk, there will be a quick survey. You could suggest future topics, speakers, things that you might be interested in. You'll see that on your screen in a minute. Please take a moment to fill that out. It helps to make sure the content is what is going to be helpful for the audience. So on behalf of the ACM, Mauricio, and myself, thank you for joining us, and I hope that you'll join us again in the future. That concludes this talk for today.